Hello everyone. Today I'm going to talk about the binary tree pre-order traversal. Given the root of a binary tree, return the pre-order traversal of its nodes' values. Um, so the pre-order. Okay, so we go 1, 2, 3. 1, 2, 3. Null, it does not have a left child. So that does not get added. So I want to solve this with a stack. So first const stack and pass in the root as the head of it. So first while we have something to process, we will process elements using a while loop. So stack dot length greater than 0. So while there are things in the stack, which we initialize it with a root. So if the root has left or right children, we want to add them to the stack. So let's see if node dot right. So if it exists, that's a Boolean value. Node dot right is Boolean, true or false. It's null. If it exists, it's true, and we push it onto the stack. If it does not exist, then nothing happens. And then we do this for the left side. We can do else if. We can also just, because this is not like going to stop this is a Boolean. If this is not true, doesn't matter, doesn't affect this one. So we can just do another if node.left stack.push node.left. Okay, so we push it on to node.left, and from there, once they're added to the stack, okay, so we're adding the elements to the stack. If there are indeed children to be added, they will be added if they are in existence, while stack.length is greater than 0. We want to add them to the result. So result.push the value node. You can't just say node, you got to say node.value, because node is an object that contains a pointer and the value. So the left and right pointer and the value. So we need the value. And we want to push that onto the thing. But also, when we process an element, we want to remove it from the stack. So and so what are we treating as the node? The node is going to be the element that's on the top of the stack. So const node equals stack dot pop. So we pull something off the top of the stack, and we're ready to process it. We store its value in the result, check if it has children, and add them to the stack. Now that they're in the stack, we can move on to the next element in the stack. Now this is going to be the 2 children, so they're going to check if those children have children, and it's going to store the value and pop it off the stack when it processes it. So every time it sees a value, that gets taken out of the stack. And we just keep going on in this cycle, and at the end, we need to return the results. Semicolons are optional, because this is JavaScript, and it's a funhouse language. Is not defined. Const results equals.